So if you look at this question number 4, we see that you two are locked. Okay. Let's go back to this one real quick. Jump to 4. So they gave us a differential equation, and then they gave us points to graph the slope. Okay, that slope field. And then B says find a particular solution. They give us a f of 2 is 3. That's our x and y value. And then they want us to approximate using a tangent line. So go ahead and read through these questions, make sure you're good with it. Our problem now is this related rates question, and we haven't done these in like 6 months. So we're gonna go over some questions like this, not specifically this one. I'll leave this to you guys. And then I want you guys to have that resource so you guys can go back and look at those possible questions. Again, these are all on Schoology, posted as FRQ sets. So take advantage of that. If you guys work through most of these questions, I think it's a great way to prep for it. You can never fully prep because things change. Like the questions are asked, we're not quite sure what they're looking at. But remember, the test calculators are optional; they're not going to be required. So a lot of these questions where they're required a calculator as a must, they probably won't ask them in that way. All right. So I want to just go over today related rates. These types of questions. Okay. There's a couple of them on here. Those are in your homework, and that's posted back here as FRQ related rates. And I didn't get an optimization out, but I'll keep looking for some optimization. So related rates and optimization. So I'm gonna add some optimization to that a little later. We have related rates. So we're gonna look at this practice. And this here. So let's go ahead and kind of set this up for us. A square is inscribed inside a circle. The radius of the circle is increasing at a constant rate of 0.8 centimeters per second. So as we mentioned before, we want to write out our rates of change. So our rates of change here was the radius is increasing. So dr over dt is equal to 0.8 centimeters per second. Centimeters per second. And this is a constant rate. Oops, what's going on here? Okay, there. Okay, so when the side square is 4 centimeters, what is the area of the circle? Include units. Okay, so we read the question. The sides is 4 centimeters. What is the area of the circle? A square is inscribed inside a circle. Okay, so let's see. So I don't know where to start. I'm just gonna try it. When the side of a square is 4 centimeters, what is the area of a circle? Area of a circle is pi r squared. So in order to find the area, we need to find the radius. The radius can be defined this way, or it can be defined this way. Now the radius is the same, r and r. Well, since this is a square from geometry, we know that if this is 4, this is 4, it's a 45, 45, 90, because it's a square. So this is 4 square root of 2. We cut that in half. Pi r squared, where r is going to equal to 4 square root of 2 over 2. So our r value here is going to be 2 square root of 2 squared. That's the area. Area is equal to 4 times 2 pi, which is 8 pi. Part B, when the side of the square is 4 centimeters, what is the rate of change in the area of a circle? So this is where related rates come in, where they ask us now what's the rate of change. So we know we have pi r squared. That's what we said we had already. So let's go ahead and find the derivative of this to find what they want, the rate of change of area. So dA over dt is equal to 2r r prime. Anyway, we're going to call it dr over dt. You can see that also. And pi. That's a constant. Okay. Now, looking at what we start off with, we're given dr dt. Dr dt was 0.8 centimeters per second. So we're going to rewrite this as dA over dt is equal to 2r and then point. Actually, no, we can plug some of this stuff in. We know what the radius is. Radius is 2 square root of 2. And dr dt, we said we know that is 0.8. Let's write this as centimeters. Centimeters per second, I think, per second. And then we're left with pi. So dA over dt is equal to, you can multiply that out if you want, but I want to make sure I'll get that units in the end correct. Centimeters, oh, sorry, times 0.8 pi centimeters squared per second. Okay, and that's the units. You can, of course, multiply that out or leave it. If you want to multiply 4 times 8 is 32 square root of 2 pi. Okay, let's take a look at C. When the radius of the circle is 5 square root of 2 centimeters, what is the rate of change in the shaded area of the region outside the square, but inside the circle? Oh my goodness. Okay, so we have a circle, we have a square, and we have the shaded region, which is outside the square, but inside the circle. Well, what? So, okay, I say what, but I'm going back and actually rereading this part. What is the rate of change in the shaded area? Well, let's talk about what is the shaded area. The shaded area is the circle, which is pi r squared minus the square, which we defined it as, not r, call this r over 2, right? What is the area of the square? That's going to be, you can say s squared is the area of the square, but what's the s? S is, how do I write this in r? S is r times 2, right? 2r, this is r, times 2, and then we divide by square root of 2. You guys remember that rule? Let me show you guys a triangle. If I say this is 5, 5, this is 5 square root of 2. If I say this is 15, 15, 15 square root of 2. But what if I give you the hypotenuse first? What if I say this is 4? This is 4 over square root of 2. 4 over square root of 2. So if I multiply by 4 over square root of 2 times square root of 2, we end up with a 4. So to go backwards as we divide. So for me, the s side, s is equal to 2r over square root of 2. So we're going to say pi r squared minus 2r over square root of 2 squared, because I want them all in the same variable. And then the next thing, when the radius is 5 over 2, so we want to use radius, what is the rate of change in the shaded area? So let's go ahead and find that rate of change now. So we're going to take the derivative of this to find how fast this is changing. So we take the derivative. So this is area of the shaded region. So dA over dt, I'm calling DAS for shaded. It's going to be 2 pi r dr over dt, chain rule, minus 2 parentheses 2r over square root of 2. That's the power rule. That's the power rule over here. Multiplied by the inside. Well, that's like 2 over square root of 2 is a constant. So 2 over square root of 2, and the derivative of r is dr over dt. Okay. think I did that correctly. Let's double check. Derivative of the front is 2r dr dt pi. And then the derivative of the back, bring down 2 first. And then that's a constant. So we just write the derivative of r is dr dt. Okay, I think we're kind of okay. We know what my r value is. It's, this here would be 5 square root of 2 pi. We know that dr dt is 0.8 minus, we can multiply that. 2 to 2 is 8 over 2, the square root of 2, and r, which we said was 5 square root of 2, and dr dt was 0.8. Okay, and then the units, this would all be centimeters, centimeters squared per second, because it's area. Okay, I include the rubric on these. You just want to take a look. And these look like similar answers, I think. I hope. Yeah. Oh, they call it ds here, so they left it as s. And you could have done that. Okay. So just as a reminder for related rates, it really is, even looking at this one, if you guys remember the cone problems, the trick to cone problems was that we had to create a right triangle here, and that right triangle changed with our graph. So write the formula. Okay, water is poured into a conical tank is 24 feet tall, and the diameter at the top is 20. So that's the ratio that's not going to change, 24 and 20. Write the formula of the volume of the cone in terms of h and height of the water tank. So they want us to find the volume, which is v is equal to 1 over 3 pi r squared h. And we want to write the volume in terms of h, so only h. So we want to make r equals to what? So our gimmick was that we draw a smaller triangle inside, and this is h and r. And h and r follow this relationship. R over h is equal to 20 over 24. So if we want to solve for r is equal to 20 over 24 h. We can reduce that by 4. So r is equal to, divide by 4 is 5 over 6h. And then we just want to change r for 5 over 6h.
Radius is 10 though, isn't it?
The radius, oh, sorry, no, it says, thank you, you're right. The top of the diameter was 20, I misread it. Thank you for catching that. If this is 10, we can only divide by 2. The number changes. 10 over, so 5 over 12. Okay, thank you for catching that. Next question following up is when the volume of water is increasing. So volume is increasing at cubic feet per minute. So we know that's a rate change in volume, dt. And that's 3.4. We're looking at cubic feet, feet cubed per minute. The height of the water is 2 feet. What is the rate of the height changing? So the question was dh over dt. Oh, good job, Abner. Sorry. Thank you, Abner. So if you look back at our original equation of here, if I take a derivative of v and take a derivative of h, that gives me my dv dh that we need. Okay. So I want you guys to go ahead and work on that and practice that. So I'm not going to finish that one. You guys can finish it later when you guys look through this. And the last one is the radius of the surface of the water of the tank is increasing. Okay, the surface of the water in the tank is increasing at 0.75 feet per minute. The radius of the surface of the water. So gr over dt, the radius of the surface of the water, is equal to 0.75 feet per minute. At what rate is the area of the surface changing when the radius is 4.2? So the rate of the area, so they're looking for dA over dt, and the area is the top, top surface of the cone. So that's pi r squared. So we can say pi r squared is my area. And we want to get to dr dt. So we take the derivative. How to get from a to dA dt? How to get from r to dr dt? That's just the derivative. dA over dt equals to pi 2r dr over dt. Then we have everything we need. So hopefully, as you guys go back to look at these related rates problems, I would say go back and look at your notes. There's different types that we saw. We saw the ladder one. We saw a shadow one. Sometimes they do that boat problem. Also, you can take a look at the four free response questions that we did. That I did put on the homework page. And again, this one here, that's more like a funnel, right, than an actual cone. So they actually give us the equation for that funnel. That's nice. Okay. And they're going to say find the volume, find the average radius when it's draining. Probably this. Okay. Oh, look at this chart one. If you remember this derivatives. So take a look at this one also. Okay. Any questions about related rates?
Yeah.